Problem number 7. I want to write a trig statement linking the 23 degrees, the 10, and the W. What I need to do is think in terms of SOHCAHTOA. What pieces do I have? I have an angle, I have the opposite leg, and I have the adjacent leg. That makes me think of tangent, of the TOA part of SOHCAHTOA. Tangent of 23 degrees, the tangent ratio would be opposite, the W, over adjacent, the 10. And so I've accomplished what I needed to do. Letter B says, let's get the W by itself. I can do that by just multiplying both sides here by 10. The 10's cancel on that one side, and so now I have W equals 10 times tangent 23 degrees. I can approximate that value of W right on the calculator by simply typing it in. I need to be in degree mode here, and then type in 10 tangent 23. We get about 4.24. Number 8 is a similar problem. We want to write a statement that links up the 20, the z, and the 56 degrees. Let's see, this time I have the adjacent side to the 56, and I also have the hypotenuse. So that makes me think cosine. In SOHCAHTOA, CAH, cosine, adjacent over hypotenuse. So cosine of the 56 degrees is equal to the 20, the adjacent, divided by the hypotenuse. I want to solve this equation for z. That's going to take me a couple of steps. I can clear the fractions like I did the last time. That'll give me z times cosine 56 equals 20. Then to get z by itself, I would have to divide both sides by that cosine 56 degrees. And I'm done. Z is equal to 20 divided by cosine 56 degrees. Once again, I can simply type that into the calculator to get a decimal approximation. 20 divided by cosine 56 looks to be about 35.77. Problem number 9. We're given an angle. We're being asked to draw the angle in standard position. Always start on the positive x-axis. 90 is positive, so I'll rotate in a counterclockwise direction. Here is the angle 90 degrees. And then somewhere along the terminal side, I'm simply being asked to mark the coordinates of any point. So pick a point and name the coordinates. Well, this is pretty wide open. You're going to have to use 0 for the x-coordinate because you didn't move left or right. You can really pick any positive number you want for the y-coordinate. I'll just use 1. That's about the simplest thing I can do. So 0, 1 is certainly a point on the terminal side. 0, 2, 0, 3. Letter B, the angle negative pi. So I'm going to rotate in a clockwise direction. Pi is 180. So that'll take me to right here. I want the coordinates of any point on the terminal side. This time my y-coordinate will be 0 because I'm not going up or down. My x-coordinate will be some negative number. The simplest choice would be -1. I could use -2 or -3, something like that. And then the third one, let's see, 405, it would probably help me to know how far past 360 this angle is. If I subtract, I'm going to get 45 here. So 405 means rotate all the way around once and then go 45 degrees more. So here's my angle in standard position. Now this one looks a little trickier. I'm supposed to end up with some point over here on the terminal side. Well, it's not as hard as you might think. If I drop a perpendicular here, these two lengths represent the coordinates that I'm trying to find. Well, remember I went 45 degrees past one full revolution, so look what we've created. It's a 45, 45, 90 right triangle. Well, that means the two legs have the same length. The easiest situation is the one where we label this 1, 1 square root of 2. I think that's the one I'll use. That means the coordinates of this point would be 1, comma 1. But I could have also used 2, comma 2, 3, comma 3, 4, comma 4, etc.